Okay, so this has to do with the corrections that you try to do for your quiz. I think there's something kind of, there's a little misunderstanding here, okay? Alright, so for this problem, a to the negative 1 times b squared, you said that's equal to a times b cubed, right? So I was thinking what you probably did was you probably thought that somehow you had to combine these two powers, and then this a power disappeared somehow, and then you get b cubed, right? Okay, here's what you need to understand. The only way that you can ever combine powers is if the base are the same, okay? Again, keep this to heart. The only time you can combine powers is when the bases are the same. A is not the same as B. It's saying that A is different than B. So you really can't do any kind of combination like add 1 to 2 or okay? So the only thing you can do is just rewrite this, this little expression. Remember, if you saw my previous video when we talked about negative powers and stuff, okay? Well, all we can really do is just rewrite this negative power into a positive power, right? So, if you look here, a to the negative 1 times b squared, remember, a to any negative power means that it's a fraction, right? So, a to the negative 1 really means what? 1 over a to the 1, right? Alright, multiply that, because this means multiplication, by b squared. So really all you're really doing is multiplying a fraction times b squared, right? So we know that any number we can rewrite that as a fraction, so that's b squared over 1. So, if we just do multiplication of fractions, right, just multiply the top numerator, 1 times b squared is b squared over, and the a1 times 1 is just a1, but again, we don't use a1, right? It's anytime you have a to the 1, just write that as a. Okay, so any power to the 1 power, you don't even need to write the 1 power, okay? So for example, if we had 2 to the 1, that's just 2, okay? Or x to the 1, that's just x, okay? Alright, so it should be b squared over a. Alright, so you really can't combine these two things, okay? So always check for the base. Make sure they're the same. If you have a and then b, you can't combine these two. But if you have a and a, well then yes, you can combine these, right? You're multiplying two exponents of the same base, okay? So be careful of that. Okay, let's look down here. Let's see, you had 2x cubed y to the negative 3, right? 2x cubed, that means times y to the negative 3. And you came up with 2xy cubed. So I'm assuming you kind of did some of this more, this combination thing where you combine these 3's to get the y to the 6. Again, what we talked about before, if you don't have the same bases, right? You can't combine the powers, there's just no way. Alright, so the only thing you can really do is just rewrite this little expression. So the only thing we can really do to this thing, okay, is just change the negative powers into positive powers, right? So to do that, that's going to be 2x cubed. Okay, let's look here. Remember, it's y to the negative 3rd power. We can rewrite it as a fraction. So that's going to be 1 over, so multiply that, 1 over y cubed, right? Because we always rewrite negative power into positive power like that. Alright, so all we're doing is just multiplying, fractions. So it's 2x cubed over 1. Multiply the numerators, that's 2x cubed over y cubed, okay? So I know we talked about, the product rule, quotient rules. Now those rules only apply if you have the same basis, but you don't here, right? You have an x and a y. You can't combine them like that. A and B can't combine them like that, okay? You can only just rewrite these negative powers into positive powers. That's really the only thing you can really do here, okay? Alright, so next video I'm going to go over the square root stuff. Okay, let's talk about these square roots. I'll be honest, when I saw your work, I was confused what you're doing. I think, and honestly, yeah, I know you think you know what you're doing, but I think at the same time, you're actually confusing yourself also, okay? So, I think the way you write these square roots is also very important, how you read them, and then how you decipher them, alright? And to show them correctly, okay? So let's look at the first problem. So we have square root of 121 x to the 6 times y squared, okay? And the answer came out to be 4y cubed times y square root of 11. Technically, I guess you could combine these, but there's some problems. Where did x go? And I'm not quite sure square root of 121 is 4 times square root of 11. Okay? So, alright, first things first. Alright, always write a square root and put whatever you do under the square root, okay? If you don't do that, then I think you can get some complications here, okay? Alright, so let's look at the number, 121, okay? Now, the square roots you guys are doing, alright, these numbers, the square roots, you're most likely going to have stuff that are perfect squares where you can like times the same number together, like 9 times 9, right? Which is 81 or something like that. So, if you have like this number 121, well, that's not a very common number, but you have to ask yourself, is that a perfect square? So how would you know if it's a perfect square? You're going to have to do trial by error, okay? So, is it 9 times 9? What's 9 times 9? 81. That's too small, right? What's 10 times 10? 10 times 10 is 100. That's still too small. Well, what about 11 times 11? Let's try 11 times 11. Okay, 11 times 1 times 1 is 1. 1, 0, 1, 1. So let's add numbers. We have 1, 21. So the magic number here is 11. Okay, 11 times 11. So we know that's going to be 11 times 11 x to the 6th power y squared. Alright, make sure you put it underneath the square root so you know that everything's underneath the square root. Okay? We can rewrite this, right? Because we now have 11 times 11 as 11 squared, right? You know, like how you're doing exponents, like 2 times 2 times 2 is 2 to the cubed, right? Because you got 3 2's, right? So that's why 11 times 11 is 11 squared. Alright? X cubed y squared. Now if you remember the identity of square roots, right? If we have something like something squared, the square root is just going to be that number, right? So, the square root of 11 squared is just 11, right? Alright, and then this part, I think you kind of did correct, but maybe this might be an x, not a y. Alright, so here, x cubed, right? Well, not x cubed, x is 6. To take the square root, we have to divide the power by 2, right? So what's 6 divided by 2? 3. So we're going to get x cubed. And then y squared, well, that's like a perfect square, right? So if we square root that, we just get y. So my guess is that this thing right here, you probably meant x cubed, right? Alright, so I think you pretty much get, understand, about the variables that you're supposed to just divide by 2, right? The powers. And then, I think the only really mistake was really right here. But when I was looking at your work, you didn't, rewrite these square roots and stuff. And honestly, I think that might have confused you, okay? So make sure that always put all your work underneath the square root. And then after, after all that you could have done, then take the square root, alright? I think that's very important. Well, let's take a look at this next problem. This next problem can be kind of tricky. Why? we have an x to the 7th and y to the 8th. This x to the 7th is an odd power, right? It's an odd number, 7. So we're going to have to work this a little differently. Okay, we're just going to work it like we usually work it, right? So let's break down the numbers of 72. Well, that can be what? 9 times 8, right? 9 times 8, and then x to the 7th, y to the 8th. That's equal to, see what I did? I just recopied down what I had, right? Even though this might be more work, it's more clear, okay? Alright, we can rewrite 9 as 3 times 3, or 3 squared, right? And then 8, we can rewrite that as 4 times 2, right? 4 times 2, x to the 7th, y to the 8th. That's equal. Alright, so we have 3 squared times, what's 4? 2 squared times 2, right? We have a little 2 left over, right? And then x to the 7th times y to the 8th. Okay. Now we're going to have to tackle this odd power, this x to the 7th. Alright? So this is what you do when you have odd powers. So let's just rewrite these numbers. Okay. So if you have an odd power, like x to the 7th, what you're going to do is that this odd power, we can rewrite it as x to the 6th times x. X to the 6th times x. So in other words, we can rewrite it as an even power that's 1 less than the odd number, right? Because what's 1 less than 7? 6, right? So we can write it as an even number, or even power that's 1 less than the odd power times the base of the exponent itself. So it's, in this case, x to the 6 times x. Let's say if we had x to the 9, right? We can just rewrite that as x to the 8th times x. Okay? So this is any odd power. Trust me, any odd power. So if we have x to the 7th, right? It's going to be this, right? What's 7 minus 1? 6. So it's going to be x to the 6th times x. X to the 6th times x is x to the 7th. Why? Because remember the product properties? Alright, we can add the two powers together. That's going to get 7. And then we have y to the 8th. Okay, now we can take the square roots of everything, okay? We have 3 squared. That's going to come out 3 times, we've got what? So we'll just cross that out. 2 squared. Okay? Cross that out. 2, we can't do anything to that. X to the 6. Okay, so we divide 6 divided by 2, which is 3. So we have x to the x cubed. Cross that out. Okay, and then we have an extra x. We leave that in. Y to the 8th. 8 divided by 2 is 4, right? So we get y to the 4. Alright, then we're going to have some stuff left over in here, right? So 3's cancel, this 2 square cancel, but we still have a 2 left in there, right? And an x. So underneath the radical, what we call the radicand, is 2x, because we have a 2 and an x left over in there, right? And what comes out is this. And then we can further simplify by saying that this is 6x cubed y to the 4th times 2x. Now I don't think you're going to get too many of these problems in your test, but I mean you still have to kind of work it, because I think I only gave you like 2 problems, so but you have to understand how it works. So again, in this case, if you have an odd power like this, x to the negative, not x to negative, x to the 7th, right? We have to make sure that we rewrite that as x to the 6th times x. Okay? So again, any odd power that you have, we can always rewrite it as an even power that's 1 less than the odd power times itself. So if we had x to the 11, that's equal to x to the 10 times x. And then we can take the square root of x to the 10, can't we? Right? So you always have something left over in there. Alright.